Hello everyone. So today we are going to analyze the vehicles when they take turn on a circular track. So this is a topic basically from the chapter circular motion. So let us analyze the situation what is provided to us. So basically this is a top view of a road on which a car of mass m is moving with a constant velocity v, and the coefficient of friction of this road is given as mu. The radius of this circular track is given as r. So what we need to find is the V max at which this car can take a safe turn without skidding. Do you know what is the meaning of skidding? Skidding is basically when you take an unsafe turn such that the car moves away from the road. So now, to analyze the situation, first of all, let us draw the free body diagram of this car. So, while drawing the free body diagram of this car, I am considering the back view of the car. So here the situation is top view. When you view this road from the top of it, so you will feel that this car from four wheels is moving along at a constant velocity v. But if you view it from the back, you will see only the rear wheels. So this car is going into the road. You can feel it. So this is the center of the circle. This is the center of the circle. Now, we know the concept in the circular motion that whenever a particle performs a circular motion with a constant velocity v, its tangential acceleration is 0. So here only the centripetal acceleration will come into play. And what is the value of centripetal acceleration? It is v square by r. So here the centripetal acceleration of this car is equal to v square by r. Now, let us analyze the forces which will be acting on this car. First of all, it will be the normal force which will act perpendicular to the surface. Next, it will be the mg force that will act perpendicular to the car. Now, what is the third force that will act on this car? It is the friction force. But the question is, where this friction force will act and what kind of friction will it be? Because we have got two types of friction. That is the static friction and the kinetic friction. So here, in the case of turning of a car on a road, at the moment when the wheel comes in contact with the road, the point which comes in contact with the road, it immediately comes to rest. That is, in this case, the friction that will act is the static friction. And what is the quality of static friction? It acts that much, how much it is needed, and in the direction where it is needed. And here, since the acceleration is along the center, so this static friction will act along the center. So this is the static friction Fr. Now, this static friction is responsible for providing the centripetal acceleration to this moving vehicle. Now let us do the force analysis in both the directions and derive some equations. So if I do the analysis in the vertical direction, so this m will balance the mg. This will be my first equation. Along the center, if I write the force equation, so this Fr will be equal to mass of the car into its centripetal acceleration. This is basic Newton's second law. Now, I have to find Vmax. In this expression, if you analyze, if I have to maximize the velocity, then I have to maximize Fr because mass and radius are constant properties here. So now, to maximize this V, I need to maximize Fr, that is, I can write this equation for my situation as Fr max is equal to mass into Vmax square divided by R. Now, what is the maximum value of static friction? This you must be knowing from the chapter friction and Newton's law of motion. So, the maximum value of static friction is coefficient of friction multiplied by the normal force, that will be equal to mass into Vmax square divided by R. Now we have to just substitute the values and we will get the value of Vmax. What is the value of m? It is equal to mg. I am writing here. So this is mu into m into g, that will be equal to m into Vmax square divided by R. This m will cancel. And from here, I get the maximum velocity of this car as square root of mu g r. So this is the maximum velocity at which this car will take a safe turn on this particular circular track. Now note that this was a rough circular track. Let us analyze this Vmax which we have derived just now. What if we increase the car velocity above this Vmax? What will happen? See, if you increase the Vmax, can you increase mu? Can you increase g? No. So on the right hand side, only r can be increased. That is, when we drive the car above this maximum velocity what we have derived, the car will follow a greater radius. That is, if you follow a maximum velocity greater than the maximum velocity of this car, then what will happen? If you take a turn, then you will tend to move away from this circle because the radius will increase, and as soon as you move away from the radius, then you will hit this boundary, you will hit it, and the case of accident will happen. So this was the Vmax, and also you can analyze this that in the rainy season, okay? In the rainy season, what happens? This mu, coefficient of friction, decreases. Now why I am saying it decreases, I will explain it in a bit. Mu decreases in the rainy season. So during the rainy season, what happens? When water comes on the surface of road, it becomes slippery. So automatically the coefficient of friction will reduce. And you must have noticed that while you are driving on a rainy season, then you tend to reduce your car velocity while taking a turn. Why? Because this mu decreases, and simultaneously you have to decrease this maximum value of mu, maximum value of v actually. So in rainy season, you tend to take turns on less speed. Okay, we analyze this. Now let me ask you one question. This was a case of rough road. What if I make it a smooth road? This time I am removing this friction. Now I don't have any friction force on this road. Now my question is, will you be able to take a safe turn? Since in the last case, this Fr was the force which was providing the centripetal acceleration, but in this case I have removed that friction force. Now, will there be any force to provide this centripetal acceleration? The answer is no. That is, in case of smooth horizontal circular tracks, we cannot take a safe turn. So this was the situation that what are the forces which we are going to act upon the car when it is going to take a turn on a circular track. So previously I discussed that on a smooth horizontal circular track we will not be able to take a safe turn because there was no force to provide the centripetal acceleration. Now here I have modified the situation and I have banked the road to an angle theta for this horizontal. You must have noticed this situation on the racing tracks or on the highways where the steep turns are made. You can visualize this situation from the back view as if the car is going and this angle is theta from which the road is banked. Now let us analyze the forces here. So the normal force is that like this, MGP force downwards. Now this is the horizontal axis, vertical axis. This angle is theta, then this angle is 90 minus theta, this is theta, then again this angle will be theta. Let us break down the components. If we write the components here, then this will be n cos theta is equal to mg, and here the n sin theta, this is the radius r along which this car is performing the circular motion. So this n sin theta will be equal to mass into the centripetal acceleration of the car. So what have you noticed here? The edge of banking. This normal component, sin theta component, has performed the centripetal acceleration. So this is the edge what we get while we bank the road. From here also we can calculate the speed v, which comes out at under root of r g tan theta.